So today we are here to discuss the topic statistical process control. Myself, Shwetabh Singh, working as an assistant professor at KIET Group of Institution, Ghaziabad. Statistical process control introduction. Now the primary purpose is to tell when you have the problem. So when the problem occurs, you have to go for the statistical process control. It is basically invented by the Walter Shewhart at AT&T, and the purpose is to minimize the process tampering. Whenever there is a process tampering, we have an option to go for the statistical process control and check whether the process is in control or out of control. So unnecessary process changes increases instability and increase the error rate. So so when you continuously changes your process, instability continuously increases and error rate will increase because the changes in process will lead to the changes uh, changes as per the team requirement. So next is monitoring the production process to detect and prevent the poor quality. So we have to monitor the production process in order to detect and prevent the poor quality. Now, in the statistical process control, we have to continuously talking about the sample, not the what the sample is. Sample is basically the subset of items produced to use for the inspection. Now, for example, if you have a lot of 1,000 pieces, then you pick only a 5 items from the 1,000 items. Then 5 is said to be the samples. So basically, these samples are used for the inspection process. So the basic of SPC is to minimize the process tampering as well as minimize the process changes, because process changes will lead to the instability and error, and continuously the error rate will also increase. Now the variability will occur due to the two process. First is random. How it will occur? It will occur due to the common causes. It is basically present. It is basically present, and it is the inherent part of a process, and it can be eliminated only through the improvement in the system. Okay. Second type of variability attached with non-random. Non-random is a special causes type variability. It occurs due to the identifiable factors, and it can be modified only through the operator or the management action. So random cause will only be eliminated with the improvement in the system, while the non-random causes will only be modified with the help of operator or the management actions. Now basically we move towards the control charts. Now what the control chart is? Control chart is to monitor, control and improve the process performance over the time by studying the variation and its source. Now here you look, there are some important terms. First is to monitor. You have to monitor it, control and improve. What you have to control? You have to control the process performance, and over what parameter? You have to control over the time. What and what factor you have to be control? You have to control the variations and its source of occurrence. So so whenever a part is produced on a large scale, then there will be the variation, because there will be the variation of process, there will be the variation due to the machine handling, and there will be a variation due to the changes of operator. Okay, there these are the some causes which led to the changes in the variations and led to the variations. So control charts used by you and your team depends upon the types of a data which you and your team have. So control chart basically you and your team have to be developed, and what you have to do, you have to simply collect the data. Okay. So data here are of two types. First is the variable, and second type of data is attributes. Now, now we move towards the types of data. So what are the variable types of data? Variable types of data are those which we can measure. For example, the length, diameter, volume, time. So these are the quantity which we can measure. So it comes under the data of variable. What are the data belongs to the attributes? These are the data which we can count. And what we will count? We have to count the number of percentage defective items, number of defects per items, or the type of a defect. So when we have to measure, we have to go for the variable type data. So when we have to count the thing, for example, we have to count the defective parts or the defective items, then we have to go for the attributes type of data. So in the later slides, we have to deal with the control charts of for variable data as well as control charts for the attribute data, which we can see later on. Now we have to move towards the control charts for the variables. Control charts for variables are of two types. Here we use X bar chart and R chart. So first of all, we have to deal with the deal with the X bar chart. What is the X bar chart? X bar chart is to monitor the changes in the mean of the process. So what you have to deal here is you have to calculate the mean and you have to check the variation of a process as compared to the mean. Okay. And what is the use of R chart? Use of R chart is to monitor the dispersion or the variability of the process. So in the case of R chart, you will check the value as compared to the mean, that how your value disperse with respect to the mean value. Now here it is a certain type of a process control chart in which there are three type of limit defined. First is upper control limit, second is process average, third is lower control limit. Now here you see this is the mean part. Okay, this is the mean value and the variation of your process will record it as compared to this mean value. Sometime the process will occur above this value, okay, and below this value, but a process must be exist within these two limits. And why the process must be exist within two limits? We have to go for the next slides. Okay, what is this? A process is in control if no samples points outside the limit, most point near the process average, about the equal number of points above and below the center line. Fourth is point appears randomly distributed. Okay, so what the first point is? First point say no point will lie above and below the control limits. Okay, here this point is lie above the upper control limit, so this sample number is particularly out of control. So what the quality manager do? The quality manager will send this back to the supplier and give it remark that this sample is below the quality. Okay, so the next part is now when we plot the data recorded, so we get a curve that is known as bell curve, and the data follow a normal distribution type possibilities. So here it presents a bell curve. Here mu is equal to 0, it generally represents the mean value. Okay, and your process and your variation in the process will recorded as compared to this mean value. So when we move toward the positive value, here we write as sigma. Sigma is known as standard deviation. This is the deviation means that process must be deviate from the mean value. Here all the process will occur with a perfect quantity with no error rate, while when your process deviate, it will attain a certain value of sigma. Okay, so mu is equal to 0 is your process average value. Here is 1 sigma, 2 sigma and 3 sigma, and what it represents? 95% represent that 95% of a sample will lie within this curve, so the quality is within the control limit. Okay, so 99.74 sample is which lie between the 3 sigma. That means 3 sigma is here, 3 sigma is here. So 6 sigma basically covers the possible quality of 99.74% sample, which is absolutely right. Okay. These are the points we already discussed it. So no sample point outside the limit, most point near the process average, equal points. Now here we do the classification of the control charts. Control chart basically divided into two parts. First is the process control, second is the product control. Process control means we have to control the process. So we have to go for the variable. Variable means job dimensions. And for the job dimensions, as we discussed earlier, we have to go for the two type of chart, X bar chart and R chart. Now second classification is the product control, where we have to go for the product specification. So we have to go for the defective or non-defective. So defective or non-defective will comes under the attribute type of data. So here the three type of a chart will come into the picture: P chart, NP chart and C chart. So now X bar chart. X bar chart means, in this chart the sample means are plotted in order to control the mean value of the variable, as we discussed it earlier. What is the R chart? Sample ranges are plotted in order to control the variability of a variable. Now these are the some certain values which you plot over the statistical process control chart. So in the earlier case we just discussed about the three control limits. So here one by one we will discuss it. What is all about the upper control limit, what is all about the lower control limit, what is the central limit. So for the X bar control chart, upper control limit is X. It is basically the X double bar plus A2 into R bar. Okay, LCL is X double bar minus A2 into R bar. CL is X double bar. Okay, so here is some correction. UCL is X double bar plus A2 into R bar, X double bar minus A2 into R bar. Central limit is X bar. So if what is this A2? These A2s, if we will discuss it later on. If the standard deviation is given, upper control limit is X double bar plus 3 sigma. So here X is replaced with the X double bar. So here is also X double bar is also present. Okay. Now the upper control limit is D4 into R bar. Lower control limit is D3 into R bar. And control limit is equal to R bar. Okay. Now we discuss one by one with the help of some examples. Let there is a samples of 10 and sample size 5 you will pick among the samples, and slip ring diameter is being recorded. So in the case when n is equal to 1, these are the lot size. Okay, don't be confused, these are the lot size, and in this lot you just carry the 5 samples for the inspection purpose. So for the one, these data are recorded. So how we calculate the mean value? Mean value is this plus this plus this plus this plus this divided by 5. Okay, so you will get this value. And how we define the range? Range can be defined by the maximum value minus the minimum value. Okay, what is the maximum value? Maximum value is 5.02. What is the minimum value? Minimum value is 4.94. So you can calculate the range. So by this you calculate the mean value. What does this parameter define? This parameter defined x1 bar, x2 bar, x3 bar, x4 bar, x5 bar, x6, x7, x8 bar, x9 bar, x10 bar. So total sum is 50.09. Here summation R comes out to be 1.15. So what we will get, summation of x bar you will get is 50.09. Okay, summation of R is 1.15. And what is n? N is your total number of lot, that is 10. So how will you get x double bar? This is x double bar. X double bar is x summation of x bar divided by number of sample. This is 10. So it is this thing value. So how you calculate the R value? R bar is summation of R upon 10. So this x double bar and R bar, these are the central limit values. Okay. Now upper control limit, how you calculate the upper control limit? X double bar plus A2 into R. So how you calculate the A2? See, there are the 10 lot amongst which you select only a 5 sample size. So here sample size is given and different values are given for the X chart and for the R chart. So here sample size is 5. So you pick this A2 is 0.58, D3 is 0, D4 is 2.11. So these are the control chart factors. So here you can simply put the value x double bar is 5.009. Okay, just put it plus A2. How we calculate the A2? A2 is 0.58. Okay, into R double bar, R bar, sorry, R bar is this much. So you get the upper control limit value. Okay, how you calculate the lower control limit? Lower control limit value is this much. Okay, how you calculate x double bar minus A2 into R bar. Okay, similarly for the R for the range chart, upper control limit is D4 into R bar. How you calculate the R bar? R bar is this. Okay, And D4 is how much? D4 is 2.11. So this value you calculate, okay? 0.243, and LCL is 0 because D3 is 0. Now we generally go for the plotting of X bar chart. How you plot the X bar chart? Here on Y axis you just plot the X bar. Here you just plot the subgroup values. So sample group is 10, and how you calculate the X bar? Now see the subgroup value of 1. What is subgroup? Subgroup value 1 is this, and what is the x1 bar value? 4.98. Okay, so f1 for the first value is 4.98. Okay, okay, and for second is, for sample number 2, x2 bar is 5. Okay, so x2 bar is 5. Similarly, x3, x4, x5, x6, x7. So we can plot up to the x10 value. Okay. Now draw the UCL. Where does your UCL lies? UCL is 5.075. So it is below the 5.08. So mark UCL. How you plot the LCL? LCL also say similarly to UCL. LCL is 4.943. So 4.943 is here, and control limit line is x double bar. Now join all these dots corresponding to mean var value, and you plot this type of curve. So generally go for the point which lie above the UCL and which lie below the UCL. So here is only the subgroup number 9 which lie above the UCL. So this sample is out of control. Okay. So this is the process how we can check the quality of our lot. Similarly, we can plot the R chart also. How you can plot the R chart? Here you just mention the range. Here you mention the subgroup. So how you calculate the range? So for the sample number 1, range is 0.08. Okay. So here let's see. For the first sample, point is 0.08. Okay. Similarly, for the second, you can plot. For the third, you can plot. For the fourth, you can plot up to the 10. Similarly, plot the UCL, LCL, and control limit. Generally, what it deals with is generally basically said to you that these samples are variably dispersed as compared to this center line. Okay, so this is all from my side.